Alright guys, welcome back. So I'm going to go over the review for the first test. So this is the first exam on chapters 1, 2, and 3. Okay. And by the way, these go in order in which we covered them throughout the course. So, alright, let's start with number 1. It says identify the fallacy in the given argument. When confronted with questions from the press about alleged scandals, a congressman replies that the allegations against him should be ignored since his accuser is part of a vast right-wing conspiracy. So this is a personal attack, okay? Because instead of addressing the allegations, he basically just, calls his accuser or brands his accuser part of this vast right-wing conspiracy. So this is going to be personal attack, or also known as ad hominem. That's Latin for like attacking the man, or anyway. Okay, number 2, very similar. Each of my friend's 3 cats catch mice. And then the conclusion is, therefore all cats catch mice. So this is an example of hasty generalization. Okay, just because you've seen your friend's three cats catch mice doesn't necessitate, from a logical perspective, that all cats catch mice. All right, number 3. A television commercial shows 2 people who fall in love while visiting a certain amusement park. Okay, so this is going to be an appeal to emotion. So they make you believe that if you visit that same amusement park, then you're going to have, just as an enjoyable and ecstatic experience as this couple here. Number 4, you should brush your teeth every day because brushing your teeth is very important. So this is circular reasoning, okay, because you're basically stating the premise, you're using the premise as your conclusion. You haven't really addressed the question, why is brushing your teeth very important? And I know you probably see these, the software doesn't do a very good job on generating new questions. Number 5, after getting new dishes, I started to sneeze. And the conclusion is, therefore, I must be allergic to the new dishes. Okay, so this is an instance in which we have one event preceding another, and we conclude that prior event is causing the second event. And that is an example of false cause fallacy. All right, so that would, have covered chapter 1, dealing with those logical fallacies. So now we're going to get into some conversions. So this would pertain to chapter 2. So number 6 here, it tells us also, be careful, pay attention to how it wants you to input your answer. It says we went around to 2 decimal places. So a stockbroker sold 35 shares of stock for $36.64 each. So what was the total amount of the sale? Okay, so you're going to start out with 35 shares of stock. I'm going to zoom in a bit and get a little more room to write. And I'm going to multiply this by, this is my conversion factor right here. It says that basically $36.64 per share. So I can write that. I need my dollars to go on top. So $36.64 per share, and my 1 share to go in the denominator so that my shares will divide out. Okay, and so it looks like all we're going to have in the denominator are some 1s, so we're not going to worry about that. We'll go ahead and multiply those numerators. Let's see here. Oops. So 35 times $36.64 per share. And this is going to give us $1,282. And it says 0.4, but to 2 decimal places, that would be 40 cents, okay? 4 tenths is the same as 41 hundredths, or 40 cents. So this one is going to have to be choice A. So it's multiple choice. So, okay, number 7. This one says round to 2 decimal places as well. It says, assuming that your heart beats 70 times per minute. So this is sort of like your conversion factor right here. 70 times per minute. How many times does your heart beat in 6 days? So you're going to start out with 6 days. Okay. And what we're going to have to do here, before we can convert this, or before we can utilize this conversion factor here, is we're going to have to get our days down to minutes. Okay, so I need a conversion factor to take my days down to hours. I'm going to say that 1 day is equal to 24 hours. And notice, I want my day in the denominator so that it'll divide out. Okay? And then, well, I'll go ahead and divide these out. Days divide out. And then I need to take my hours down to minutes. Okay? So I know that in 1 hour there are 60 minutes. So now that unit hours, that unit of time, will divide out. And now is when I'm going to plug in my last conversion factor, the fact that a heart beats 70 times per minute. Okay? So now my minutes will divide out. And so we're going to be left with, we're not going to have anything left in the denominator, but we will be left with the number of times that the heart beats over this 6-day period. So we're going to have to multiply all those numbers in the numerator. All right, so it ends up becoming 604,800. Okay, times in that 6-day period. So this one will be choice B. All right, so we'll continue. Number 8 says a commuter train travels 51 kilometers in 35 minutes. So we want to express the speed in kilometers per hour. Okay, so we're going to start out with what we're given, 51 kilometers per 35 minutes. Okay, and then we need a conversion factor. We're trying to get the speed in kilometers per hour. So we're not going to convert the kilometers, but we need to convert the minutes to hours. Okay, so we know that there's 60 minutes in an hour, and I need to put the 60 minutes in the numerator and the 1 hour in the denominator. The reason is, guys, because I already have this unit, minutes, in the denominator over here, so I need this other unit in the numerator so that they'll divide out. So this is an instance in which you've got to put the unit that you want to cancel in the numerator. And so when you divide that out, our units that we're going to have left over, we're going to have kilometers over hours. And then we're going to have to multiply the 51 and the 60 and then divide that by 35. So you can do this all in one step. You can say 51 times 60, hit enter, and then divide that by 35. And we're going to get, let's see here, how do we need to round? It says round to the nearest tenth. So the tenths place has a 4 in it. So we look to the right, so it's going to stay a 4. So this will become 87.4 kilometers per hour. Okay. And And, well, you would put that in here, 87.4, and then you've got to select your unit. It's kilometers per hour. So this is sort of a two-part question. All right, number 9 says you can buy hair product in a 15-ounce bottle for $4.95 or in a 12-ounce bottle for $3.84. So which is the better deal? Okay. So this is, again, an instance in which we're trying to find the unit price, which is the price per quantity. So for the 15-ounce bottle, it is $4.95, and it's 15 ounces. So let's divide this out. $4.95 divided by 15. We want to, okay, so it's exactly 33 cents. So 33 cents per ounce. And then for the 12-ounce bottle, well, you can, this one is kind of, oh, okay, never mind. Yeah, for the 12-ounce bottle, it's $3.84 for 12 ounces. So we'll divide this. This is going to be close. It's hard to really tell just by looking at the figures. Ooh, 32 cents. Well, it was really close, wasn't it? So it looks like the 12-ounce bottle is just 1 cent cheaper, okay? Which is the better deal? It's going to be the 12-ounce bottle. Yeah, that's slightly a better deal, okay? It's hardly, I mean, you're going to save like, what, 4 cents on the total. But anyway. All right, we'll continue. Number 10. It says, convert the measurement to the units specified. Round your answer to the nearest tenth. So 99 kilometers per hour to miles per hour. So let's start with what we're given, 99 kilometers per hour. And we want to convert this to miles per hour. So we're not changing the hours, but we do need to convert the kilometers to miles. So this is similar to the other one. So you might have to look this up, but I believe, well, let me look it up just to be doubly sure. Kilometers to miles. Okay. Yeah, so 1 kilometer is equal to 0. I'm just going to call it 0.62 miles. So 1 kilometer is equal to 0.62 miles. Okay, so I need to plug this in. I need my kilometers to cancel though, so I need to put the 1 kilometer on bottom and the 0.62 miles in the numerator. Okay, so those divide out. We're going to multiply straight across. So 99 times 0.62, that gives us 61.38. And this is going to be in miles per hour. Alright, so to the nearest tenth, the 8 would bump the 3 up to a 4, so it's going to be, oh, this is interesting. Well, probably the discrepancy is due to the fact that I didn't carry out as many digits as maybe I should have when I copied down the conversion factor. Okay, but you guys can clearly see that this has got to be the appropriate choice. All right. So number 11. What is the total cost of 2.5 cubic yards of soil if it sells for $22 per cubic yard? Okay, so we're starting out with 25 cubic yards. And again, the price is our conversion factor. It's $22 per cubic yard. Okay, so $22 per cubic yard. So our cubic yards are going to divide out. So this is a nice one because we don't have to convert the cubic yards to cubic feet or anything like that. And so we end up just going to multiply 2.5 times 22, and that'll give us the number of dollars. And that's going to be exactly $55. Okay. Also, don't repeat the dollar sign, guys, because it's already in here. See that? Some students will do that. Okay, number 12. Convert 6 years to hours, neglecting leap years. Okay, so 6 years to hours. So we assume that because we're neglecting leap years, that we have 365 days in a year. So let's start with 6 hours, or excuse me, 6 years, and then we'll multiply by. We know that 1 year has 365 days. Okay, so that would cancel out my years. And then I need to go from days to hours. So I know that 1 day has 24 hours, and that will divide out my days. And now I've got my unit hours. So we just need to multiply straight across here. So 6 times 365 times 24. That gives us 52,560 hours. Okay. Let's see. Alright, number 13 says use the currency exchange rates in the table for the following question. As you leave Winnipeg, so this is in Canada, you convert 275 Canadian dollars to US dollars. How many dollars do you receive? Okay, so we're converting Canadian dollars to US dollars. So let's start with 275. An abbreviation for Canadian dollars, guys, is this, CAD. Okay. Now, we need to look in this chart, and if you remember how I explained it, I like to use the first column. The first column says dollars per foreign. Okay, so what that means is that 1 Canadian dollar is equal to this many US dollars. Okay, so, well, I'll write it here. 1 Canadian dollar is equal to 0.7828 US dollars. Alright, well, I want my Canadian dollars to cancel, so I'm going to put the 1 Canadian dollar in the denominator, and then my 0.7828 US dollars in the numerator. So the Canadian dollars divide out, and I'm going to multiply straight across. So, according to this chart, the Canadian dollar is not worth as much. It's lost some value. 275 times 0.7828, and this gives us 215.75 or 0.27. Okay, $215.27. And it does say round to 2 decimal places, by the way. Okay, number 14. Here we're converting temperatures, okay? We want to convert 75 degrees Fahrenheit into Celsius. So you're going to have to go back and look at your notes to find the formula. Let me look in here. So I'm going to go back to the 2ABC notes. And here it is. Okay. So we're trying to go from Fahrenheit to Celsius, so I'm going to use this formula right here. And I'm going to copy it in the notes. Celsius is equal to degrees in Fahrenheit minus 32 divided by 1.8. So I'm going to plug 75 in for F. So 75 degrees Fahrenheit minus 32 degrees divided by 1.8 is equal to, do the subtraction in the numerator first. And that's going to give us, we want to round to the nearest hundredth. So this second 8 is going to get bumped up to a 9. So this is going to become 23.89 degrees Celsius. And that's going to be choice B. All right, number 15. Same question, same type of question, we're just going in reverse. We want to convert degrees Celsius into Fahrenheit. So you could go back and look at your notes, and for that we'd be using this formula. We're going from Celsius to Fahrenheit. Okay, so it's just the opposite of this one. It's 1.8 times C plus 32. And so we'll plug negative 20 degrees Celsius in for C. We'll get 1.8 times negative 20 plus 32. You have to do the multiplication before the addition. You remember your order of operations. Times negative 20. Hit enter, and I'm going to say plus 32. This says round to the nearest hundredth, but it comes out to be an even negative 4 degrees. Negative 4.00 degrees Fahrenheit. All right. So we're getting there. Number 16 says write this number in ordinary notation. So it's expressed to us in scientific notation. Okay. So the way I think about it, guys, is 10 to the 7th is a big number. So I need to move this decimal 7 places to the right, because moving it to the right will make it a big number. So 4.56, if I move it 7 places to the right, I'm going to end up having 5 zeros that I have to fill in. Okay? So you just look over here, and it looks like it's going to be choice A, which is 45,600,000. All right, and then number 17 is going in the opposite direction. We've got 69 million, and we want to express that in scientific notation. Well, the decimal's understood to be at the very end, so I would have to move it all the way over here between the 6 and the 9. It becomes 6.9 times 10 to the, I moved it 7 places, okay? Now, it's got to be a positive 7, because when I move that decimal between the 6 and the 9, I'm making this number really small. So to offset that, I need to make this power of 10 really big. That's why I use a positive 7 instead of a negative 7. So this is going to have to be choice A. All right, number 18. Here we're doing some arithmetic with numbers expressed in scientific notation. All right, so part A, we're multiplying these two. Okay, so we've got 3 times 10 to the 4th multiplied by 2 times 10 to the 6th. Well, if you remember, you're going to multiply the 3 and the 2 times, and then you're going to multiply your 2 powers of 10. 10 to the 4th times 10 to the 6th. Okay, so 3 times 2 is 6. And then multiplying these powers of 10, you add those exponents. So 4 plus 6 is 10, so you get 10 to the 10th. So in scientific notation, this will become 6 times 10 to the 10th power. All right. Now the next one here is addition, okay? Well, the addition, guys, what we had to do is convert each of these two numbers in ordinary notation first, then add them, and then convert it back to scientific notation. All right, so 5 times 10 to the 4th. Basically, there's a decimal right behind the 5, so you're going to move it to the right 4 decimal places. And if you do that, it's going to become 1, 2, 3, 4. It's going to become 50,000. Plus, let's convert this one. The decimal place is right behind the 6. I'd move it to the right 3 places, and that would turn it into 6,000. And so 50,000 plus 6,000 is 56,000. And then finally, to convert it back to scientific notation, the decimal is right here at the very end, so I've got to move it between the 5 and the 6. So that becomes 5.6 times 10 to the, well, I moved it 4 places. And by moving it to the left, I'm making this number really small, so I need to make my power of 10 big. So it's got to be a positive 4 and not a negative, okay? So 5.6 times 10 to the positive 4th. All right, and then lastly, we've got the division here. Let me write it out. We've got 6 times 10 to the 14th divided by 3 times 10 to the 11th. Well, this means that we divide the 6 and the 3, okay, times, and then we divide the 2 powers of 10. So 10 to the 14th divided by 10 to the 11th. So 6 divided by 3 is just 2. And then when you're dividing these powers of 10, you have to remember that you subtract the exponents. So 14 minus 11 is 3. So you're going to get 10 to the 3rd power. So that is our quotient, written in scientific notation. All right. Okay. So we don't lack much more. I think we only have 22 questions on the review, and I think the test has 20 questions. Okay. Let's look at number 19. It says, determine whether the statement makes sense. And if the statement is possible, or it says, if the statement is possible, then it makes sense. If it is clearly impossible, it does not make sense. Okay. All right, so that was some clarification as to what it means to make sense. So it says, yesterday, the number of gallons of gasoline used by people driving cars in the United States was 7 times 10 to the 10th. Okay. All right, well, to get an idea here, think about your powers of 10. 10 to the 3rd is equal to 1,000. Remember, these go in threes. 10 to the 6th, that's equal to 1,000,000. 10 to the 9th power is equal to 1,000,000,000. Okay. And then 10 to the 10th would be like 10 billion. Okay. So 7 times 10 billion would be 70 billion, essentially. So the question, so now we're trying to see, does it make sense that in one day 70 billion gallons of gasoline would be used by people driving? Okay, so to think about this, you have to think, you sort of have to know what the population of the U.S. And I believe, well, hold on a minute. Yeah, the U.S. I believe that it's around 300 million. Okay. And so, let's see, 300 million. What you could do is divide the 70 billion by 300 million, and that would give you the number of gallons per person. To me, this is not making sense, okay? I think this is going to be a lot of gasoline. So 70, and then a billion has 9 zeros, so you could literally type in 9 zeros. That's 3. That's 3 more. That's 3 more. Then we'll divide this by 300 million, because this is roughly what the U.S. population is. So type in here. I need to make, well, okay, 300, and then a million has 6 zeros. So go ahead and type in 6 zeros after that. There we go. Now I'm going to hit enter. And this gives me 233 gallons. So guys, that to me does not make sense. That every person would use over 200 gallons of gasoline a day. So I'm going to go with no on this one. Alright, so if you have one on this, guys, just remember those powers of 10. Okay, think about it like this and try to figure out what that power of 10 represents. I'm going to check the answer key real quick for number 19. Okay, yeah, it doesn't make sense. Okay, number 20. Same type of question here. It says, in her lifetime, my grandmother saw about 6 times 10 to the 7th hours of commercials on TV. Okay. All right. Well, 10 to the 7th. Okay, so let's do this again. We know 10 to the 3rd is 1,000. 10 to the 6th is 1,000,000. So 10 to the 7th would be 10 million. So 10 million times 6 would be 60 million. Okay? 60 million. So 60 million hours of commercials. That already is not making sense to me. But, you know, to be sure, let's say that this is an average grandmother and she lives 80 years. Okay? So what we could do is we could divide her lifespan by the number of, or no, let me do it the other way. We could divide the number of hours of commercials by her lifespan, which was 80 years. That would give us the average number of commercials per year. Okay? And then we could break it down to days if we want to help us put it into perspective. Alright, so I'll do this real quick. So 60 million. So a million has 6 zeros, so I'll just punch in there 6 more zeros divided by 80 years. And that would be about 750 hours per year, okay, of commercials. All right, so maybe I'm still not convinced, so now I want to see, well, what would that be in hours per day? So we know that there are 365 days in a year, so I could divide this by 365, and this gives me the number of hours per day. Well, this clearly is a no-go, because how could she watch 2,000 hours of commercials when there's only 24 hours in a day? Okay, so this is clearly not possible. Now, sometimes, you know, when I saw 60 million hours, I knew there was no way that could be. There weren't even 60 million hours in her life. She would have to have lived for hundreds, if not thousands of years to have even been able to watch this many hours of commercials on TV. All right, so, okay, number 21 here. The population of the U.S. in 2000 was roughly 280 million. Express this as the number of people per square mile. And then it tells us that the land area of the U.S. is roughly 3,536,000 square miles. Okay? So what we need to do is take the number of people, which is 280 million people, per the total number of square miles. You know, we could write this in scientific notation if we wanted to, but I'm just going to keep it in ordinary notation. Square miles. So when I write my unit down here, I want to make sure that I square those miles, okay? And guys, I'm just going to divide these out in my calculator. So 280 million, so I need to type in 6 more zeros. And I'm going to divide that by 3,536,000 square miles. And this comes to 79.2 people per each square mile. Okay? And so you can see that rounded to the nearest person, it's going to be 79 people per square mile. A square mile, guys, is actually a really large unit of space, unit of area, okay? It's literally a square that goes 1 mile this way and another mile in the other dimension. That's a big, you guys are probably familiar with acres. An acre is really small. It's tiny compared to a square mile. So anyway, all right, we got one last one. All the answers are down here. So number 22, it says write the number in ordinary notation. Well, this is just a little bit more practice with scientific notation. All right, so I'm multiplying by 10 to the 5th. That's a big number, so I want to make my decimal big, so I'm going to move it to the right 5 places. So I'll get an extra 0. So this will become 212,330. So this looks to be choice B. Okay? Alright guys, well I had thought initially about doing this in 2 videos, but I was able to get it in under 40 minutes, so that's not too bad. So take this practice, take this review as many times as you need to prepare for that test. Your test is going to look just like this. Okay? Alright, well, I'll see you in chapter 4.